All right, let's just jump right into it. Welcome to This Explainer. Today we're tackling a piece of everyday magic that, honestly, we all pretty much take for granted. You turn a key or, push a button these days, you press your foot down, and suddenly this massive, heavy metal machine is blasting down the highway. But what's actually happening under the hood? We're going to demystify the four-stroke engine and uncover the completely wild, high-speed choreography that literally turns liquid fuel into your daily commute. So here's the big mystery we're unraveling. How exactly does liquid fuel become forward motion? I mean, it's so easy to just pump gas and completely forget about it once it vanishes into the tank, right? But the journey of that fuel is one of the most ingenious feats of modern engineering. We're going to break down how your engine harnesses the energy trapped inside that liquid and actually uses it to spin your wheels.
Here's our quick roadmap for today. First, powering your daily drive. Second, meet the moving parts. Third, the four-stroke cycle. Fourth, the bicycle pump analogy. And finally, speed and scale.
Okay, Section 1. Powering your daily drive, from fuel to motion. Basically, your engine is just an energy converter. It takes liquid fuel and turns it into the mechanical motion of pistons pumping up and down inside cylinders. That motion, that is the heartbeat of your car. Moving right along to Section 2. Meet the moving parts, the engine's cast. Before we get to the main event, we gotta meet the players. Let's run through them. First, the cylinder. It's the sturdy metal chamber where the actual burning happens. Inside that is the piston, a solid block of metal that slides up and down, fitting perfectly inside the cylinder walls. Then, the spark plug, the vital little guy that provides the electrical zap to ignite our fuel. Up top, we have the valves. Think of these as heavy-duty trapdoors that let air and fuel in and exhaust out. Overseeing those doors is the camshaft, which is basically the conductor, making sure they open and close at the exact right microsecond. And finally, sitting at the bottom of it all, the crankshaft. Now, the crankshaft is absolutely crucial. Its whole job is to convert the up and down motion of the pistons into rotational motion. Why does that matter? Well, your pistons just bounce straight up and down, but your wheels need to spin in a circle to actually get you anywhere, right? So, as the pistons plunge downward, they push on this crankshaft, forcing it to spin. That spinning motion goes right through your transmission and out to your tires. It is literally the bridge between the internal explosions and the rubber hitting the road.
All right, Section 3, the four-stroke cycle, the core mechanics. Now that we know who's who, let's watch him work.
This whole engine cycle is broken down into 4 distinct steps, or strokes, of the piston. Step 1, intake. Step 2, compression. Step 3, power. And Step 4, exhaust. Every single time your engine is running, every cylinder is doing this exact 4-step dance on repeat. Let's build it from the top.
Step 1 is the intake stroke. The intake valve pops open and the piston drops down inside the cylinder. This creates a massive vacuum, literally sucking in a perfectly measured mix of air and fuel. It's like the engine is taking a huge deep breath in, getting all the ingredients ready for the fire.
Right after that deep breath, we hit Step 2, compression. The valves snap perfectly shut, so the chamber is completely sealed. The piston reverses direction and shoots back up, violently squeezing that air and fuel mixture into a tiny little space at the very top. Squeezing it like this makes the fuel incredibly volatile. It's kind of like coiling a heavy-duty spring as tightly as you possibly can.
And boom, Step 3, the power stroke. This is the main event. The mixture is fully compressed, the spark plug fires, and bam, ignition. The burning gases rapidly expand, but because the chamber is totally locked down, the explosion has nowhere to go but down. So it slams into the top of the piston, driving it downward with immense force. Out of all 4 strokes, this is the only one that actually creates the raw power to move your car.
Finally, Step 4, the exhaust stroke. After the explosion, the cylinder is just filled with useless, burned-up gas. The engine has to clear its lungs, so the exhaust valve opens up, the piston swings back up, and pushes all that leftover smoke out into your exhaust pipe. Once the piston hits the top, the exhaust valve closes, the intake opens, and the whole thing starts over. Intake, compression, power, exhaust. Over and over again.
Section 4, the bicycle pump analogy. A familiar feeling. If all this metal and fire sounds kinda abstract, I bet you've actually felt this exact physics with your own 2 hands.
Think about a standard manual bicycle pump. When you pull the handle up, you feel it sucking air into the tube. That's exactly like the piston dropping during the intake stroke. When you push down, especially when the tire is getting pretty full, you feel that hard resistance, right? You're manually compressing the air,
just like the compression stroke. Now imagine if, right at the bottom of your push, a tiny explosion fired off inside the pump and violently slammed the handle back up into your hands. That intense pushback, that's your power stroke. And if you unhooked the pump to just push the leftover air out, you'd be doing the exhaust stroke. It's the exact same push and pull physics, just happening with exploding fuel instead of your arm strength.
Okay, Section 5, Speed and Scale, the big reveal. We walked through this slowly, but what's actually happening in your car is completely insane.
Just think about the number 3,000. When you're cruising down the highway, it's super common for your engine to be running at 3,000 RPM, revolutions per minute. That means the crankshaft is spinning a full circle 3,000 times every 60 seconds. That four-step cycle we just talked about, it's happening thousands of times a minute in a literal blur of metal and fire.
Let's put that in perspective. At 3,000 RPM, a single cylinder is firing off about 25 power strokes every single second. 25! Just count 1 second in your head. Ready? 1. In that tiny flash of time, the valve opened, piston dropped, mixture squeezed, spark fired, explosion happened, piston slammed down, and exhaust pushed out. 25 separate times. And most cars have 4, 6, or even 8 cylinders doing this all at once, perfectly timed. It is an absolute masterpiece of engineering.
So, I want to leave you with this. Next time you hop in the driver's seat, are you going to feel those thousands of controlled explosions powering your trip? It's so easy to just view a car as a quiet, comfortable box that magically gets us to the grocery store. But right under your feet, there's this furious, high-speed loop of physics. Intake, compression, power, exhaust, working relentlessly to turn a tank of liquid into pure forward motion. I really hope this explainer gave you a brand new appreciation for the absolute magic of the 4-stroke engine. Thanks for hanging out with me for this explainer today, and keep an eye out for the wild mechanics hiding in your everyday life.